While deciding the topic for inquiry, we found this video on YouTube.
Just put as much instant coffee as you need. Water that goes in there. And that is the hot chocolate effect.
An interesting phenomenon, we decided to investigate it. This is the hot chocolate effect.
Our aim is to investigate the reasons and the physics behind the hot chocolate effect. Dependent variable is the pitch of the sound when the mug is hit. Independent variables are the amount of water, amount of coffee powder, and the temperature of the water. Controllable variables are same spoon, same mug, same coffee. These were our equipments. We first investigated our lab by playing around the equipment and the basic knowledge we have. We put the coffee powder in hot water, which was not boiled, and hit it with a spoon to hear the difference of the sound in terms of pitch with our ears. We realized that hitting bottom works better after trying several times, which was different from the video given to us. Adding to this, we discovered that the effect does not last long, so it was needed to be done quickly. These were our procedures.
The wavelength of a sound is constant for a given volume of fluid. This means that velocity is directly proportional to frequency, and pitch is increased when frequency is increased. So when the substance, coffee in this case, is put into water, it creates many tiny bubbles which lower the speed of sound in liquid. If speed of sound is decreased, it means that the pitch is also decreased. So at the beginning, when the mug is hit with a spoon, it starts off with a low pitch. However, as the mug is being hit with the spoon, the bubbles rise to the surface and burst, which increases the velocity, therefore increasing the frequency. That's why every time you hit the cup, the pitch increases as the more bubbles reach the surface and burst, as the frequency rises as the speed of sound in the liquid increases.
As for inquiry part, we decided to change the amount of water, amount of coffee powder, and the temperature of the water. First, we changed the amount of water. We obtained the data for 100 ml, 150 ml, and 250 ml. As for the results, we noticed that pitch goes up faster when there is lesser water. Here is a video for 100 ml water with 1 teaspoon of coffee.
1 spoon.
Now, listen to the 200 ml one with 1 teaspoon of coffee. You can clearly hear that the 100 ml one went up much faster. The physics behind this is that the lesser water there's lesser space for air bubbles to exist, which means that air bubbles goes up to surface and bursts faster. Therefore, velocity increases faster, and when velocity increases faster, it means that pitch rises faster. Secondly, we change the amount of coffee powder we put in the coffee. We need 1 teaspoon, 2 teaspoon, 3 teaspoon, and 4 teaspoon. As for the result, we notice that pitch goes up slower as there is more coffee powder. This is the data for 200 ml 1 teaspoon and 200 ml 4 teaspoon.
200 milliliter.
We can see this from data that with 1 teaspoon pitch goes up faster. This happens because when we put more and more coffee powder at the same time, there are more air particles going inside the water, which is increasing the air bubbles in the water. As there is more air bubbles, it takes more time for the air bubbles to burst. Therefore, pitch rises slower when there is more coffee powder in the water. Thirdly, we tried cold water, which is around 11 degrees, instead of the hot water we were using. Interestingly, we found out that cold water produces a reverse hot chocolate effect, in which the pitch goes down.
Cold water, 200 teaspoons.
This happens because without the hot water, the bubbles inside the liquid does not rise. This means that as the coffee keeps going into the water and dissolving, more air bubble is produced. Therefore, pitch is going down.
Our data corresponds to the results. Just by looking at our data, it can be quite hard to tell whether the frequency goes up or not. This is why we use the fast Fourier transform graph, the FFT graph for short, to find the frequency. The FFT graph separates a wave pattern into its different frequencies. We know that the sound we're getting is not a pure frequency, it is a combination of different frequencies. From an FFT graph, we see that all the sounds have a stable frequency of 2000 Hz with varying frequencies in between. For example, let's compare the 200 ml 1 spoon with 200 ml 4 spoon. We know that the more coffee, the slower the sound goes up. We see from our graph that the first hit of both cases have identical graphs. However, the 1 spoon sample ends with a high 5000 Hz being dominant. The 4 spoon one ends with 3000 still being dominant, but a bit of 5000 Hz in there. So it is higher than the starting, but not that much higher. This is also the case with our other recordings. Hence, our data proves and corresponds with the results that we heard with our ears.
Overall, we think that our lab was successful. We were able to obtain data and videos which supported our aim. However, we found interpreting our data difficult. While we could hear it in the videos, showing the proof in data form was challenging. Until we actually did research and learned how to interpret an FFT graph. We also had few human errors which couldn't be fixed, such as amount of coffee powder we put in wasn't exactly the same amount. There's also a problem with the spoon hitting the cup twice in one stroke, as a human hand tends to do a rebounding action. While there were challenges, we think that we are able to obtain accurate and precise data. As for recommendation, we recommend new groups to do it with hot chocolate. As for inquiry part, we recommend new groups to try with different liquids such as milk and soft drinks.